Hello friends, this is Jim with Science Talk. I want to share with you two recent studies in Nature, or published in Nature, that examine what happens to storms as the warming continues. So this is a study done by U.S. governmental scientists, warning that hurricane and flood hazard is amplified by a warming world. And here's another kicker. Worst storms are caused by big cities as well. And I'll get to that later in this video segment. Worst storms are on the way. And we know that, right? Look at Sandy, Harvey, Maria. There was Katrina, kind of the first big storm that of note in the warming world. And just to put it in perspective, when Katrina hit New Orleans in August of 2005, it was an estimated over 1,800 lives were lost. And the economic damage worth in today's dollars is $160 billion. A lot of damage. However bad that was, climate change made it worse. It was global warming up to that point. Up to 9% more rain fell over the city. Some of it sweep away the river defenses and precipitate disastrous flooding, like the lower Ninth Ward, you might remember. And don't forget, as we warm the planet, the oceans are warming. Warmer water holds more energy. So now you get these cyclones above. There's a lot of energy for it to pull up, suck up, and then what are cyclones? They're really just an energy distribution mechanism for the planet, along with the conveyor belt. So now you got more energy, and we're gonna move it over from here to here, and warmer air holds more moisture. Warmer waters hold more energy, more moisture, and you're going to be pissed on pretty damn well, basically. Second study, again also in Nature, warns that big cities make bad storms even worse. Urbanization, roads, pavement, asphalt, rooftops, multiplies the risk of flooding on average 21-fold. You have this downpour of water. If you have ground, the ground can at least absorb some of it. Eventually, at some point, it gets super saturated, and the ground can't hold much more water, and then you get runoff. And if you have steep slopes, then you get massive erosion and so on. But if you have asphalt, the water's just going to run off straight away, immediately. No soaking of the ground of water. The growth of Houston, Texas, where Harvey hit, left the city at the mercy of Harvey, which hit in 2017, and the scale of flooding was without precedent. Now, the research is based on computer modeling of the impact of overall planetary warming around 1 degree C in the past century. A little conservative, it's more like about 1.3, but nonetheless, it's just to show you how even 1 degree C can be detrimental. Okay, as I just mentioned, if you have a warmer atmosphere, it can hold more water vapor. And for those geniuses that say, oh, look at the 4 feet of snow that just fell, that means global warming is all bullshit. No, that's bullshit. Warmer atmosphere holds more moisture, and you have more snow falling. It falls as snow because in the northern hemisphere, we're tilted away from the sun. So we have less direct solar energy coming in. It's going to be cooler. Duh. So this again betrays a lack of understanding of basic scientific concepts, because unfortunately most Americans, and it's a reflection of the educational system, I hate to say, but most Americans are scientifically illiterate. They do not understand basic scientific concepts. The late Carl Sagan, in his last major book that he wrote before he passed away, called The Demon Haunted World, The subtitle, and that came out in 95, 96. The subtitle was Science as a Candle in the Dark. And he was, in this book, decrying the lack of critical thinking and the lack of understanding of basic scientific concepts in the general populace. And science is a candle in the dark. This is basically saying we're in dark ages from an intellectual aspect. It has only gotten worse in the 2+ decades since that book came out. I personally think that book, among others, should be required reading for those people we call Congress people and senators, because a lot of them really don't understand science. Senator James Inhofe holding up a snowball. See, this disproves global warming. No, you moron! It actually proves global warming because it's holding, the air has more moisture and there's more snow coming down. So, here's the interesting thing. With each 1 degree C rise in temperature, the capacity to absorb moisture increases by 7%. That is a significant increase. A warmer world storms will be wetter storms. Higher temperature storms are likely to be more ferocious. You set up a greater gradient in temperature and air pressure, which will increase wind speed. Wind is basically the atmosphere in motion. And you set up a gradient, it's going to move from here to there. Just like if I open up a jar of butyric acid, I don't know why I mentioned that, it just popped into my head. Butyric acid is basically like rancid butter. But if I open up a jar of butyric acid, and I sit in the corner there, okay, if I stand immediately right by the jar, it's going to be, hold your nose, and it's like, wow, it really stinks. I can walk over to the opposite corner of the room, and eventually I will go, yeah, it stinks over here. What's happened? It went from high concentration, and the molecules disperse themselves. Things typically go from high concentrations to low concentrations, higher gradients to lower gradients. So if I have air pressure that's higher here and air pressure that's lower here, it's going to move from the higher to the lower pressure. And that movement of the air is what we call wind. So now if we create a greater disparity in the temperature, well, there's a relationship that warmer temperatures have less pressure, right? Increased volume. So colder temperatures will have decreased volume but increased pressure. So now we create a pressure gradient, and the air moves. So you have a warmer world, so you have a greater disparity in temperature between two regions. You're going to get more air movement, and that's going to translate into more ferocious storms, higher winds, basically. That's kind of the empirical concept there. Researchers have repeatedly warned that because of these simple principles, as global temperatures rise, not just the U.S., but anywhere, we'll face bigger storms, and then in the case of, say, the U.S., because they look at this, they'll face bigger economic losses. And this may possibly happen with each succeeding hurricane season. And really, the only way you're ever going to get politicians to pull the stick out of their back ends and get cracking, us scientists, we present the findings, we present recommendations, but it's the politicians that have to run with our recommendations to implement policies to change things so that we address our findings. And the only way you get politicians, hate to say it, is you have to start putting dollar amounts on the things. You start waving dollar amounts in front of their faces saying, this is causing this much damage because of what we're doing with our behavior, then maybe they'll start doing things. Houston was not prepared for what seemed like a once-in-a-thousand-year storm. But extreme rainstorms will become even more extreme, and in Texas, more Harvey-scale storms are on the way. Water that falls on forests or wetlands or coastal savanna is at least partly absorbed. Hard rain that hits asphalt, concrete, man-made surfaces basically, could swiftly become a flash flood. The latest study is a confirmation of much previous research. Now we all know what Trump did about, climate change is a hoax and pulling out of the Paris Agreement, whatever. But it's interesting to note that a lot of U.S. governmental scientists are basically saying, oh no, climate change is real. The confirmation of greater climate change danger once again comes from a U.S. government research base. Which base is it? The Lawrence Berkeley National Laboratory. Okay. Christina Patricola of the laboratory's climate division, Lawrence Berkeley, reports in Nature that she and a colleague looked at 15 tropical cyclones that have occurred in the last decade in the Atlantic, Pacific, and Indian Oceans, then built computer simulations of those storms while changing factors such as air and ocean temperatures, humidity, greenhouse gas concentrations that typically shape planetary temperatures. So in other words, what they did was they reconstructed these cyclones using the parameters that were measured of the storms, the actual measurements of these storms as they're occurring, and then they tweak the parameters up and down. And generally speaking, when it was lower humidity, lower temperatures, the storms were less nasty. Higher temperatures, higher humidity, the storms were more nasty. That's just a quick thumbnail of it. So the Dr. Petricola and her colleagues looked at the effects of climate change thus far in the shape of storms to come, and they found that warming has made rainfall between 5% and 10% more intense, but may not have so far made much difference to overall hurricane wind speeds. Let me pause there. The wind speeds are increasing, but they have not been shown to be statistically significant thus far. Important point. We want to show statistical significance. That it isn't just to chance variation. So right now, wind speeds are higher, but we cannot say at the moment, at least in their study, looking at the storms that they looked at, we cannot say with any statistical confidence that this is due to climate change, global warming, even though the temperatures are increased. Now, it may come to a point as they continue the research and get more information, more data, that they can then show statistical significance, in which case they can then say, okay, in addition to warming making rainfall 5 to 10% more intense, warming is making wind speeds faster, and that is also significant. And that leads to the second part of what they have in their report, that the winds are indeed strengthening. If the climate continues to warm as much as 3 degrees C or more by the end of this century, due to burning more fossil fuel, wind speeds could increase by up to 25 knots, which is basically another 50 kilometers per hour. And at that point, yeah, that's obviously will be a significant difference. The scientists also found that future rainfall in such storms could increase by between 15 and 35%. Yeehaw, that is a lot more. And the same computer model, excuse me, that predict windier, wetter storms tomorrow accurately predicted the pattern of the storm that had already happened. In other words, this isn't just one of the criticisms climatologists face all the time. Well, you're just models, you don't know what the hell you're doing, you're just making shit up. We take existing data when we construct our model, and we then run the model simulations to see if what the simulation does matches what was observed. And when we get that down to like, okay, this is matching what is observed, we then have the confidence to say, okay, now that we know that this model is good at predicting what the hell happened, now let's see what will be the result if we do this, if the temperature does that, if the humidity does that, if the wind speed does that, and so forth. So this isn't just willy-nilly throw stuff at a dartboard and see what sticks. We're actually basing the work on actual measurements that are taken when we create our models. And Dr. Patricola says the fact that basically all the 15 tropical cyclones responded in a similar way gives confidence to the results. So sort of like a self-auditing of your methodology, a self-verification before continuing on, as any good science would do. In a companion study, scientists from U.S. universities looked at the other component of Hurricane Harvey, the change in the city of Houston itself. In 5 days, between August 25 and 30, Harvey dumped 1.3 meters of rain, that's almost 5 feet, on the metropolis. Between 2000 and 2011, Houston had the largest urban growth and the 5th largest population growth in the entire U.S. It became a bigger target. I just painted a big bullseye right over it. With a greater area of paving and sealed surfaces, and guess what that's going to do? That's going to just, all this rain that's coming down, it's just going to channel it. Get flash floods. Here's another, almost an FU. The changing contour of the city itself helped increase atmospheric drag, slowing the passage of the hurricane. So you have a hurricane moving along, instead of just continuing moving along while dumping the water, it runs into atmospheric drag created by the building and so on, and it slows down. It's like, and it stops right over the city and just get pissing away on it. Then you throw in the asphalt and the concrete, and it's got a disaster in the making. That's exactly what happened. So the researchers included the new building made the risk of catastrophic flooding somewhere between hardly at all and up to 90 times more likely, depending on which part of the city they were looking at. Altogether, the risk of more flooding on the scale of Harvey had increased 21-fold. The message is that coastal cities must plan for the worst and keep planning. Hurricane winds and rainfall are going to intensify, increase in the future. Cities will keep on growing as human numbers increase. So planning, the author's right, planning must take into account the compounded nature of these risks, and efforts to build flood mitigation strategies must use an improved understanding of the multiple processes in place. So another case of, another situation of our human activities creating things worse for us. And just, simply with urban growth, it laid the conditions for even more catastrophic storms. So I am in preparation right now of a report on another geoengineering scheme, and I'm going to be addressing that, that what humans do will have unintended, unexpected consequences, and to think that we can anticipate all contingencies and plan for it all is hubris because of initial conditions. Anyway, thank you for your time, and we'll talk soon. Hey folks, this is Jim here reminding you to subscribe to this channel, to share my videos, tell others of the work that I do here. I also ask that if you are not already a patron at Patreon, to please consider becoming a patron at Patreon. You can find the information in the description box below the video. I'm asking you to help support the work that I do. I do not take any money from corporations or from any other sources, so the information I share with you is the actual science as it comes out of the peer-reviewed journals. So there is no BS, there's no propaganda, there's no agenda. It's just I present the science and I explain to you what it means, or at least my interpretations of it. based on my own experience as a scientist. I want this channel to grow. I consider, while I discuss many different topics here, you notice I do focus a lot on climate issues. I consider climate change to be the most pressing issue facing humanity today. Thus, I consider it important to disseminate this information to a wider and wider, more and more people. And I need your help to do this. So, yes, please subscribe. Please tell others of the work that I do here. Please share my videos on social media platforms, with your social media groups, what have you. We need to get this information out there. So for those of you who are supporting me on Patreon, I thank you greatly for your support and continued support. It does mean a lot to me. So together we can get this information to more and more people. Thank you. Thank you for your support.